Hello, this is an introduction to Thermofluid Sciences. In thermofluid system, the focus is on energy, its use, conversion, or transmission in one form or another.
The intelligent use of basic thermal and fluids engineering principles has improved the design of thermal fluid systems as diverse as buildings, oil refineries, wind turbines, metal processing plants, and cars.
Cars of 21st century are dramatically improved over those of the early 1900s.
To analyze such systems, 1, 2, or 3 energy disciplines are needed, separately or in combination. These disciplines are thermodynamics, heat transfer, and fluid mechanics.
In MEC E 230, we learn about every discipline, also the integration of the 3 disciplines for rational and complete analysis of energy systems.
No matter how complex the actual natural or industrial physical system is, we can describe it. We use assumptions to simplify the system sufficiently so that we can develop physical and mathematical models and solve them for the quantity being solved.
We discussed the concept of work and energy. Is it true that work is always associated with movements?
Kilowatt hour. Is it the unit of measurement for work or energy?
We study various modes of heat transfer, conduction, convection, and radiation, and we learn how to model them. For instance, we use electric circuit analogy to model heat transfer in energy systems.
By the way, did you know double-paned windows reduce heat transfer 2 to 3 times more than single-paned windows?
Is there any relation between the greenhouse effect and an actual greenhouse?
We study stress, strain, and forces in fluids. We discuss Newtonian and non-Newtonian fluids.
We learn how to measure viscosity.
How does water repellent fabric work?
Is there really such a thing as rain-repellent windshields?
What is a Bingham fluid?
We discuss forces caused by stationary fluids. We learn how to calculate the pressure distribution across a submerged surface.
Why is it impossible for scuba divers to explore the Titanic?
How much force is required to keep the gates of a dam closed?
Did you know that Archimedes discovered the principle of buoyancy in his bathtub? It is said that he ran naked into the street yelling, "Eureka! Eureka! I found it!" We also discussed that here.
How can we assure the stability of boats?
How much of that iceberg was seen by the lookout on the Titanic on that night? How much of it was actually below water?
And eventually, we study conservation of mass and energy in an open system and learn about the Bernoulli equation.
It takes a 12-week adventurous journey to find all the answers to these equations.
So, let's take it together.